We'll go over any questions you have. So number 1 was negative 11. If you didn't get that, maybe on your answer sheet, write what you had, but maybe cross it out. Self-score yourself, obviously. Score yourself, is what I meant to say. See which ones you're getting wrong, which ones you may need to go back, review stuff on. I'll go with the answers first, and we'll talk about how we got it. Number 2 would have been negative 8. 3 was 11x minus 4. 4 should have been b equals 4. And 5 was x equals 12. So, going back to number 1, when we put that in, put both of those numbers in, if you're using your calculator, make sure you use parentheses and put the exponent outside of the parentheses. If you put them inside the parentheses, you get a negative instead of a positive, so you end up with a different answer. So the negative 2 squared gave us, positive 4. When we multiply those together, we get negative 20. 9 minus 20 is negative 11. For number 2, do whatever acronym you use, PEMDAS, GEMS, GEMDAS, GEMS, whatever. Whatever is inside the parentheses or grouping, so add 5 and 3 to get 8. You have 2 sets of exponents, you can kind of do those at the same time. 8 squared is 64, 2 to the third is 8. You need to multiply first to get that 32. And then at this step, it doesn't really matter. You could subtract and then add, or add and then subtract. But I subtracted first to get negative 40. Negative 40 plus 32 is negative 8. Questions so far on those things? I know that those are not really things that we specifically covered here, but should be recognizable review. Number 4, what did you say? Not the small sheet, but the bigger sheet, the answer sheet, yeah. So if you didn't put your answers on your answer sheet, I would do that. It's not. Usually, I collect them, but I'm not doing that for you. We needed to solve number 4 for b to distribute our negative 7. Combine our like terms. Remember that's the same operation on the same side, not the inverse. So negative 4 plus 21. Get rid of the 14 by subtracting. Get rid of 17 by dividing. And then for number 5, same thing, you needed to get x by itself. You could have done that a couple different ways, multiplied everything by negative 4 to kind of get rid of the fraction, or the way I did it, which was move 8 by subtracting it, and get rid of the negative 4 by multiplying it on both sides. Do we have questions on any of those? So keep the answer sheet. Again, you can grade yourself. How many did you get right or wrong? I'm not going to collect this. But you can see how well you did. We're going to do one of these each week. You do have the next unit calendar. So the next 3 units we do, this one and the next 2, are all a part of linear functions. So it's like one big unit separated into 3 smaller ones. This unit is on stuff that should be or might be reviewed to you. Flows, X and y-intercepts, graphing, writing, equations. I did want to mention one last thing. So a lot of the stuff on the calendar says like, do this date if you finish. That's really dependent on how much we get through and where you guys are for each day. So these are always tentative. These days can always change. But like if we don't finish something, then dates get pushed. Just keep that in mind. We're going to very briefly start before lunch and then continue afterwards. Really just definition-wise, we'll start before lunch. You should all have these notes somewhere in those papers. So I have it written up here. We'll see if that's too hard to see, and then I'll just rewrite it another. But definition of an intercept. Can you read that, or is that too small? Okay. I'm really asking like the people in the back. I'm gonna say it out loud as well. So summarizing it, basically, an x-intercept graphically is where it touches or crosses the x-axis. Algebraically, it's where y is 0. And then for a y-intercept, it's the opposite. So graphically, for a y-intercept, it's where it touches or crosses the y-axis. Algebraically is where x equals 0. Some of you are like, I'm going to rewrite this. So if you're copying this down, pause 1 second. I'm going to rewrite it so it's a little bit bigger.
This is a big one, guys. You got to. This is all year long on this stuff. X and y-intercept. All year long. Get it in now.
Don't think I told that right. That's all right. That way you're not writing all those words. So summarize it. X-intercept where y equals 0 algebraically, and then on the graph it needs to touch or cross the x-axis. Y-intercept is the opposite. We'll finish the rest of that when we get back to lunch. So those definitions I'm not adding any more to that. For your x-intercepts, those have other names for them. So if you hear these words, just know that they're talking about x-intercepts. Solutions, roots, and zeros. All of those all mean x-intercepts. So if I say find the zeros, I'm only asking about x-intercepts, not the y-intercept. That is just called the y-intercept. Same thing with solution, same thing with roots.
Just on these intercepts, I think about the y-axis. It's like, why am I on this road? Think of the two roads, y-axis and straight up and down. You're on a cliff, you're going to die if you're on the y-axis. Right? Why am I on this road? X-axis, flat road, not much excitement on that road. So, and these are intersections. You cross them, intercept is another way, or intersection, another way of intercept. So if I cross my why am I going to die road, that's the y-intercept. If I'm on my smooth, easy sailing, no thrills X road, those are the zeros or solutions. That's the smooth road. Easy road for the solutions. The zeros are. Y-axis, you're going to die if you're on that road. Why am I on this road? Cliff.
So when we are finding intercepts, one is going to be from a graph. Can you see where they cross or touch, intersect the x and y axis? And one is going to be on grid. So for number one, where is my x-intercept? Where does it cross this line? At 2. So we're going to put it in an order pair 2, 0. Where is my y-intercept? Where does it cross this y-axis? And it might be easier if you look at your own paper than up here, just because it's right in front of you. -3. So here our x is 0, -3. Just really look at the graph, see where it crosses the axis. For number 2, what are the x-intercepts? More than one. -4 is one of them, and then 2 is the other. You can write this a couple different ways. One is listing them out in order pairs. That was supposed to be 0. So listing them as ordered pairs, or you could list them if there's multiple. So x equals, we're going to use curly brackets, my number will look back up to 10. And then least to greatest, so -4, 2, and curly brackets. So we would really only use that if there's more than one of these. If there's just one, use the order pair. What is the y-intercept? 8. So 0, 8. We're going to do one more of these together, then I want you to try some on your own. I'm going to jump down to number 6. Remember, it might be easier for you to look at your own paper than trying to see mine. What are the x-intercepts? -5 under. What was that? 3. Are there any others? 2. Yeah. So there are 3. I'm going to rewrite this down here since there's multiple. You can also write it like x and then all of these items. -5, 0, 3. What is our y-intercept? It's also 0. Sometimes that happens. So look at where does it cross the x-axis, where does it cross the y-axis, and find those x and y-intercepts. Do the other 3, and we'll come back in about 5 minutes to go over those. Nope, that's not it. That's alright. Okay. For number 3, you should have had 2 x-intercepts and 2 y-intercepts. They were both at -5 and 5. Just be mindful of how you're writing it. X-intercept, the number comes first, then 0. Y-intercept is 0, then the number. If you listed them out, you would just put them like that. X equals -5, 5, in curly brackets. And then y is the same thing. Number 4 had 2 x-intercepts, -3 and 3, with 1 y-intercept at -3. And, number 5 had 2 x-intercepts again at -1 and +5, 1 y-intercept at -3. Questions on any of those? In my personal opinion, I feel like finding them from a graph is way easier than the algebraic part. Because all you have to see is where do they cross. But we do still need to know how to do it by hand as well. So we're going to do some of these examples. I kind of meant to change the bottom part of this where it says my graphing calculator. So I could show you kind of on Desmos. I don't have my computer calculator here to show you what it would look like on your screen. But you won't have to like find them by calculator anyway. And then we'll do some other examples. So for solving this algebraically, we need to remember that if we're looking for an x-intercept, y needs to be 0. If we're looking for a y-intercept, x needs to be 0. So the very first thing, I'm going to find my x-intercept by setting this equal to 0. This right here, f of x, is the same thing as y. So if you wanted to change that to a y, you could. I'm just going to rewrite it. So f of x and y are the same thing. One just means function of, one is usually an equation, but they're the same thing. So if I'm solving for an x-intercept, I need to change y to be 0. And then I'm solving for x. So all the solving we just did, we can apply it here. we're trying to get x by itself, so move 8 to the other side. And divide both sides by 4. After solving it for x, we would see that we get an x-intercept of 2. And I can put that as an ordered pair. For y, it's the same thing, but now we're switching it. Now we need to set x equal to 0. I'm going to just rewrite this as the y. But now I'm going to put 0 in for x. And figure out what y is. Well, this is just going to become 0. And 0 minus 8 is negative 8. So that ordered pair would give me 0, negative 8. When it's in this format, so some coefficient in front of x, and then some constant by itself or some number by itself, you really don't have to solve for the y-intercept because it's going to be given to you. You can think about, well, if I put 0 in, part of that equation like disappears, becomes 0, and all I'm left with is negative 8. So if it's set up like this, we don't need to do this work to solve for y. We will see some examples where we will need to solve for y, but we'll get to those momentarily. Do we have questions on how we solve for x or how we solve for y?
What number do you put in to solve for one or the other? Find the intercept. What number do you put in?
So that's your question.
Solving for the intercept, what number do you put in for the x or y value?
0.
0. Back to 0.
Let's try some of these other ones. We're going to jump down to number 4 and find our x-intercept. For this one, I'm going to leave this as f of x. Just remember that's the same thing as y. I'm just going to skip writing that equation. You can write it as y equals so. So if I'm solving for x, I need to put what in for y? 0. And solve. Add 6 to both sides. And then either multiply both sides by 3 and divide by 2, or you can do it all at the same time and multiply both sides by this fraction split. Two-thirds times 3/2 would give us what number? 1. And 6 over 6, which is 1. 3/2 times 6 would give us what? I heard a number, but I didn't have What would this equal? Nine. This would be 3 times 6 over 1, so 3 times 6 is 18, 2 times 1 is 2. 18 divided by 2 is 9, sorry. So our order pair would be 9, 0. What would our y-intercept be? -6. So if it's in this format, that's not something you need to solve for. It's there, it's given to you already. Let's step down to 6. Same process. Put 0 in for y, solve for x. How would I solve this? Move it how? Subtract 4 on both sides. And then what? How would we get rid of that negative 2/5? We're going to do what? So I can split this to become negative 5/2 and then multiply that on both sides. Negative 5 times negative 4 is negative 20. And that would become negative 10. I'm sorry, positive 10 is what there's my brain. Did you have something missing up there?
Another thing you just got to get in your head on. When you see a variable multiplied by a fraction, you're trying to solve it. Get in the habit of thinking reciprocal, upside down. 1/2, then you go 2 over 1. 2/3, you're going to go 3 over 2. As when you multiply, 6 over 6, 6 is 1. That's what we're looking for, 1x. 2 over 2 is 1. So you see those fractions next to a variable, just think about reciprocal. 5 over 1, what are we thinking? 1/5. -3, what am I thinking? -1/3. So this reciprocal, numerator over denominator is going to be flipped over. The denominator is going to be able to do it because you're looking for 1. You're trying to get 1x and 1y.
So our x-intercept would be 10. What would our y-intercept be? 4. Positive 4. So in a moment, I'm going to let you guys go through the other ones we did not do. I do want you to jump to the last page that looks like that. Did anyone need me to go back? these look different than the problems we were just doing because it's not in the form y equals some number x then another number. These now have x and y on the same side. It doesn't mean that it's harder. You just now have to solve for both x and y. So we're going to do just a couple of these.
Think about 0. Which one is 0? The x or the y? If it's an x-intercept, y is what? 0. If it's an x-intercept, y is what? 0. The x-intercept, y is what? 0. Y. I'm a repetition, guys. You play sports, you play an instrument, it's repetition. This is the same thing. What else could be? Sports, music,
Art,
repetition. Y-intercept, x is 0. Y-intercept, x is 0. X-intercept, y is 0. Plug it in. Put a 0 in. Then you got it. Just know which one you're doing.
so just like we were doing before, same thing. Here, we'll do one where we go through it fully, and then the next one, you don't need to do it as much because you're doing kind of the same thing. But x-intercept, put 0 in for y. That's going to become 0. Solve for x. Divide by 8 on both sides. So anytime you put 0 in, one of the terms is going to disappear, and you're just going to be left with whatever term you're looking for and whatever the answer is. And then you can put that in order pair. And then do the same thing for your y-intercept. Now we have 8 times 0. Put 0 in for x now. And solve. You get 0 plus 3y equals 24. Divide both sides by 3. And y equals 8. So that was me actually putting 0 in and solving everything. What I said earlier is that you don't really need to do all of that. It's true. For number 2, if I know for a fact that if I'm solving for x, I need to put 0 in for y. When I put 0 in for y, y disappears. I can skip that step and just go on to this. And divide. Same thing with y. Now in this case, yeah. So in this case, there's nothing to solve for y. I know that I would need to put 0 in for x. It would disappear. If I had something in front of y, I could solve for it. But in this case, I can just set the y term equal to 8, and that is my answer. So it looks more complex, or maybe the other one looks more complex, I'm not sure. But it is not. You're doing the exact same thing.
Y is 0. What intercept do you find? Y is 0. What's the intercept?
For x or for y, y is 0.
Y is 0. You've got which intercept?
X. And then the opposite for, yeah. Let's try one more of these together and then I'll let you practice the other. For number 3, if I'm solving for x, put 0 in for y, that would become 4x equals 48. What is my x-intercept? Well, if I were to put 0 in for x, it would disappear, so I have negative 6y equals 48. What is my y-intercept? Negative 8. These don't get harder than that.
If you're still struggling with the algebra, we gotta get this fixed now, so this is gonna, bug you all year. Just gotta get that 1 and 2 step, equations down. You're gonna see it all year.
Really quickly, for number 5 and number 6, they're kind of trick questions, but also kind of not. If I have x equals negative 1, what we'll talk about later, and what you may remember is that this is going to be a straight line. This is my matrix graph over here. Let's say that x equals negative 1. What would the x-intercept be? Where would this cross the x-axis?
The x-intercept, y is always what? In your head, the x-intercept,
y would be
y
0,
is
yes.
always 0.
The x-intercept would be what? Negative 1. So it's kind of a trick question because they give you that, but they're trying to see, do you know that's what it is? Now in this case, this line doesn't cross the y-axis. So in this case, you don't have a y-intercept. You say y-intercept none. Sometimes that will happen only if you're missing a variable, like you don't have x and y, just one of them. If I have this matrix graph, let's say this is at y equals 5. What is my x-intercept? Is it at 0? Does it cross the x-axis? You say yes. No. So would it have an x-intercept?
At the x-intercept, what's the y value of the x-intercept? X-intercept, y is 0. X-intercept, y is 0. Do you see a 0 up there? Is there a y equals 0 up there?
So, for this one, there would be no x-intercept, because it doesn't cross it. But if I said the x-intercept was 0, that means it would have to touch at 0. You try not to confuse those two. 0 is an actual numerical value that doesn't mean anything, but it's not the answer. It's none. It doesn't have one at all. And A doesn't apply, whatever else, don't put 0. But what would the y-intercept be? 0, 5. Yes, no matter.
So it's like y or x equals just a number, the x is all going to be nothing.
It depends. So if it's y equals a number, you won't have an x-intercept unless it looks like this. Hold on. If your y value is 0, That's the only time you would have an x-intercept. But you would also have multiple x-intercepts if that was the case. Same thing with x. If x equals 0, you would have multiple y-intercepts. But that's the only time y would be something different. If it's anything other than 0 for x, you wouldn't have one y-intercept. For y, you wouldn't have an x-intercept. I've been talking too much. So I want you guys to practice. The other problems, in this section, you can try the other ones too if you want. In this section that we didn't do, along with 2, 3, and 5 in this section. And then we'll come back in about 10 minutes and go over any of those answers. On the graphing page, where we solved it algebraically, and then it said by calculator. So I'm going to do number, it really doesn't matter, but let's say number 7. You could, at home, you could do this on Desmos. On your calculator, I could show you individually how to do it, not at the moment since I don't have my computer calculator. But I would just put this in as is. Minus it's going to give me whatever it decides to graph, or whatever function this is. And then you could click on your x and y intercepts. This one, maybe it's not this one, but so I can see the y-intercept. So this would also be a good way to check yourself. So any ones you do algebraically, I would put in and make sure that I do this correctly. So like number 10 on that last page that you guys were just doing. If I put that into Desmos, or if you solved it in your calculator, put it in your calculator. I can see that it crosses the x-axis right here and the y-axis right there. So if we've got those two as y-intercept, x-intercept, those were correct. The only time Desmos will not give you the correct answer is if you don't put these in correctly, so make sure your signs and numbers are correct. I will show you the answers to these. It's kind of small, so I'm going to read them off. For number 2, x-intercept was -1, y-intercept was 2. I don't expect you to copy this down. It is on Canvas if you want that though. Number 3, the x-intercept was 7, the y-intercept was also 7. 5, the x-intercept was -4, y-intercept was 2. Did we have questions on any of those 3? The last thing said the x-intercept was 12, y-intercept was -8. 4 is not what that's supposed to say. So 4, the x-intercept was 56. That's backwards. The y-intercept was 8. 5 and 6 we did. 7, x-intercept was -1, y-intercept was -10. 8, x-intercept was -3, y-intercept was 7. Okay. So for number 8, let's find it. This one has 2 negatives. So when you're solving for y, make sure you're dividing both negatives to get that positive. 9, the x-intercept was -4, I guess I can just reconcile y was -8, and 10, we just did. But the x-intercept was like -6.25, and the y-intercept was 5. Yeah. Alright, so really quickly, you have a couple different things that are due throughout the next, however. You have one delta math on x and y intercepts that's not due until I see you again, so that's not until Monday. So you have the weekend for that. You have 2 Khan Academy assignments. One is finding intercepts from a graph. The other is finding them from an equation. They are both due on Friday, so make sure you get them done. Besides those things, you don't have anything else for me. If you did not understand anything, please come see me after school today or in the morning on Friday. I won't be after school Friday, so today after school or Friday morning. Or next week. Look at the board. Or look at your gold sheet. Either or.